This video is on section 10.2 notes, and the conic sections that we're going over today are the ellipse and the circle. So first, the definition of an ellipse. An ellipse is the set of points in a plane such that the sum of their distances from two fixed points is a constant. Each fixed point is called a focus. Plural is foci. So each fixed point is called a focus of the ellipse. So up here we have our different formulas that we're going to work with. We have another vocabulary term down here. The eccentricity of an ellipse is describes how squashed it is. So I always think of an ellipse as a squashed circle. So if you have eccentricity that is closer to 0, then you're going to be closer to a perfect circle. A perfect circle would be 0. Eccentricity is going to be more and more squashed the closer it gets to 1. So your value for your eccentricity is between 0 and 1. The formulas to find that are here and here, depending on the orientation of your ellipse. For an ellipse, we have vertices and co-vertices. Your textbook doesn't really talk about co-vertices, it only talks about vertices. So if it's asking on my math lab, if it wants to have you say what the vertices are, it's specifically talking about these. It's not talking about the ones that are on the more narrow part of the ellipse. So for the first example, we are going to find the center, the vertices, the co-vertices, the foci, and the eccentricity of this ellipse, and we're going to sketch the graph. So the center is going to be a lot like with the parabola when we found the vertex. The center of this ellipse is 2, -1. And when you find the vertices, I always think of this as kind of like a radius as an ellipse, but I think of an ellipse as having like 2 different radiuses or radii. I think of it as having one radius left and right and another radius up and down, which is technically not how a radius works, but it kind of helps my brain. So I'm going to draw that center, right 2, down 1. And then from the center, the left and right radius would be the square root of 16. The up and down radius would be the square root of 9. So square root of 16 is 4. So 1, 2, 3, 4. 1, 2, 3, 4. And then square root of 9 is 3. 1, 2, 3. 1, 2, 3. And then that's going to make our ellipse. Okay, so the vertices for this one would be left and right. The co-vertices would be up and down, and that's simply because this is wider than it is tall. So because of the 16, this is going to be a wide ellipse. And so it makes the vertices these two. So for the vertices, we have left and right 4. So 2, if I went to the left 4, that's -2. If I went to the right 4, that's +6. For the co-vertices, up 3 and down 3. So -1 down 3 would be -4. -1 up 3 would be 2. All right, for the foci, to find the C value, so here to find each focus, we have a C value instead of a P value, which is what we have for the parabola. For the C value, you have C squared is A squared minus B squared. These are your A squared and your B squared, or B squared minus A squared. Really, this just means do the bigger one minus the smaller one. So if it's wider than it is tall, then bigger minus smaller is a squared minus b squared. If it's taller than it is wide, then bigger minus smaller is b squared minus a squared. So just remember bigger minus smaller. Okay, so c squared is 16 minus 9. 16 minus 9 is 7. And so c is the square root of 7. And then I just remember that the focus or the foci is going to be along the same line as the vertices, not the co-vertices. And so that means that the foci is going to be left and right. And so from the center, from 2, we're going to go left square root 7 and right square root 7. So 2 minus square root 7, 2 plus square root 7. So that's where the foci would be. And then the eccentricity is the c value, square root 7, divided by whichever radius is bigger. And so 4 is bigger than 3, so root 7 divided by 4. This number is going to be a decimal between 0 and 1. Remember, if the decimal is closer to 0, this is more circular. If it's closer to 1, it's more squashed. So square root 7 divided by 4, so 0.66. 0.66. So they're saying this is fairly squashed, but not super duper squashed, because then it'd be closer to 1. Okay. And I'm going to go ahead and do 3 decimal places. I do not recall what my math lab wants from the eccentricity, if they want the fraction or if they want the decimal. And if they want the decimal, how many they want you to round to. So make sure you look at my math lab and see what they ask for specifically. Okay, so we found all the different things. We did sketch the graph already, and so that's all we had to do for that problem. All right, let's try again on this next one. Same thing, center, vertices, co-vertices, foci, eccentricity. So for this one, the center is at positive 5, 0. Our left and right radius is 3. 1, 2, 3. 1, 2, 3. And then up and down, it's the square root of 20. 4.5-ish. 1, 2, 3, 4.5-ish. 1, 2, 3, 4.5-ish. Okay, so the vertices would go up and down because 4.5 is bigger than 3. So vertices go up and down, co-vertices go left and right. And we're going up and down the square root of 20, and I'm going to go ahead and write that in exact numbers. So square root of 20 is the square root of 4 times the square root of 5, which is 2 times the square root of 5. And so up and down would be negative 2 square root 5, positive 2 square root 5. Okay, the vertices. The co-vertices, we went left and right 3. So 5, 0, if we go left 3, that's 2, 0. Right 3 was 8, 0. To find the foci, we're going to do c squared is bigger minus smaller. And so 20 minus 9 is 11, and so the c value is the square root of 11. The foci are always in line with the vertices, and so that means they go up and down. So from 0, we're going to go up and down root 11. So 5 negative root 11, 5 positive root 11. This graph is a little bit more squashed than the last one. So we're going to do E is C over 4.5 is bigger than 9, so we're using this one over 2 root 5. If you had to leave this in this format for the final answer, then you should rationalize the denominator. So we would multiply by root 5 over root 5 on the top and bottom. And that would be root 55 on the top, and then 2 times 5 is 10 over 10. I wish that I had paid attention to that. 2 square root 5.742. And this gave us an answer that we were expecting. This one's more squashed than the last one was, and so this decimal is closer to 1 than the last one was. All right, next we're going to take an equation that is in what we call the general conic form. So if you have x squareds and y squareds and everything over here and it equals 0 or it equals a constant, that's the general conic form. So to put the problem into the standard form of the conic, or to make it look like this, the process we have to do is completing the square. And so what I'm going to do is I'm going to get my x's together and I'm going to get my y's together. So 4x squared minus 8x plus y squared plus 4y equals, and then I'm taking this constant and I'm just going to move it to the right side. So equals -4. And now I'm going to write these out. I'm going to leave my blanks. So this one, y squared plus 4y plus blank. Over here, I have to take the 4 out of these two terms. And then I'll leave my blank after that. So my x's and my y's are going to look like this. So took the 4 out, that leaves me with x squared minus 2x plus blank. And then y squared plus 4y plus blank. Okay, so for both of these, we're going to take the middle term, divide it by 2, and square it. So -2 divided by 2 equals -1. -1 squared is +1. 4 divided by 2 is 2. 2 squared is 4. So the number that we got when we squared it, that's the number that completes the square that goes in the blank. And now we have to think about what number we added to the left side of the equation, so we can make sure we do the exact same thing to the right side of the equation. So here I have a +1, but I didn't really add 1. I really added 4 times 1. So 4 times 1 is 4. That means I added 4 to the left side of the equation, so I have to add 4 to the right side of the equation. And then over here, I have a +4 inside. There's no number in the front, so that means I really just added 4. And so I'll add another 4 to the right side. Okay, so I've got 4 times something squared plus something squared equals some sort of number over here. So I can do that real quick. These 0 out, we just get 4. Okay, so in here, whatever number you got when you divided by 2, that's what goes in the parentheses. So for the first set of parentheses, we have x's, x minus 1. For the second set of parentheses, we've got y's, and that's a +2, so y plus 2. Now, in that standard form, we want the equation to equal 1, and so I'm going to go ahead and divide by 4. Divide by 4, divide by 4, and so that's just 1 like it should be. Over here, the 4's cancel out. You will often find that these can be reduced, maybe not completely, but usually a fraction that reduces. But whatever it is, you should not have a number that stays up here. You should only have a number underneath, because that's how ellipses look once they've been simplified. So there's nothing there. I can put a 1 underneath if I want, or I could just put no number underneath at all. So this is x minus 1 squared plus y plus 2 squared over 4 equals 1. And this is the standard form of the ellipse. All right. We're going to write the equation of each ellipse, and we're going to identify the foci. So we'll do that after we write the equation. So the first thing I like to do is figure out where the center is. So left 1 down 2 looks like. So that means I'm going to have x plus 1 squared, y plus 2 squared. And then from there, I can go ahead and put the number underneath the x, underneath the y, based on how wide that part of the radius. It's not really a radius, but that's how I like to think of it. So the left and right radius is 2, and 2 squared is 4. And then the up and down radius is 1, 2, 3, 4 is 16. 4 squared is 16. So this will be 16 right here. Okay, so this is the equation of the ellipse. The foci, c squared is the bigger one minus the smaller one. We got to simplify that. So that's the square root of 4 times the square root of 3. So c is 2 square root 3. So the foci is in line with the vertices. So from the center, we're going to go up 2 root 3 and down 2 root 3. So the foci, -1, -2, minus 2 root 3, -2 plus 2 root 3. Okay. Over here, we'll find the center. There's the center of the ellipse. Right 2 down 1. So we're going to have x minus 2 squared, y plus 1 squared. Okay, so the radius going to the left and right is 1, 2, 3, 4. 4 squared is 16. Up and down is 1, 2, 3. 3 squared is 9. So that's the equation of our ellipse. And then to find the foci, we're going to say c squared is the bigger minus the smaller. C squared, 16 minus 9 is 7. And then we go from the center, we go the wider distance or the taller distance. And so from the center, I'm going to go left and right square root 7. So left square root 7, right square root 7. Okay, next we have a circle. So here a circle is a set of all points in a plane such that their distance from a fixed point, the center, is a constant, which is the radius. So determine the center and radius and sketch the graph of this. This is a circle in that general conic form, and so we're going to write it in the standard form of a circle, which is pretty familiar to us, but we're going to do it again just in case we are rusty. So the first thing I'm going to do is get my x's together and get my y's together. This is going to feel really similar to the problem that we just did right here. Now, what's going to make it different from an ellipse is that an ellipse has to have different coefficients for x squared and y squared. That's what makes them have a different radius, a different left-right radius, a different up-down radius. So they should have different coefficients for x squared and for y squared. The numbers should be different. For a circle, you're either going to find x squared and y squared like this, where they just don't have coefficients or the coefficient is 1, or you're going to find that they have the same coefficient, 9x squared, 9y squared, negative x squared, negative y squared, 5x squared, 5y squared. So they'd have to be the same or just not have them. Okay, so you'll notice they look very similar, but they'll turn out a little bit different as we write the equation. So I'm going to start off the process the same, x squared plus 4x And since I don't have a number to divide out, I'm going to go ahead and start putting these in my parentheses already with my blanks. So x squared plus 4x plus blank, y squared minus 2y plus blank. They already have the constant on the right side for us. Okay, and then just like we did with the ellipse, we're going to take these middle terms and divide by 2 and then square them. So 4 divided by 2 is 2. 2 squared is 4. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. And so here we're going to add 4, and here we're going to add 1. So if I added 4 to the left side of the equation, and it was just a 4, there's no coefficient to multiply it by. If I added, sorry about that, my watch keeps going off. We added 4 to the left side of the equation, then we have to add 4 to the right side of the equation. If we added 1 to the left side of the equation, we have to add 1 to the right side of the equation. Okay, so we have something squared plus something squared equals a number, and the number over here, 11 plus 4 plus 1, gives us 16. And then what we put in parentheses is whatever we got when we divided by 2. So x plus 2, y, and a negative 1. So here's the equation of our circle. And this is the circle in standard form, but you could actually make this equation equal 1, just like we do with an ellipse if you wanted to. You could just divide by 16, divide by 16, divide by 16. And then you can see like, oh, it's kind of similar to an ellipse, but I can see that it's different because an ellipse always has one number underneath that's bigger, and that's where the vertices come from, and one number that's smaller, and that's where the co-vertices come from. And with a circle, they're the same. And so that would, it's just a circle because the radiuses are all the same. All right, so I'm going to go ahead and graph this. We've got the center, negative 2, 1. The radius is 4. Okay, there's our circle. And if we wanted to show, it didn't ask you, it's not going to ask you about the eccentricity of a circle, but if you wanted to see it, remember we have to use the C value. Eccentricity is the C value over, it could be B or A, whichever one is bigger. In this case, that's weird because they're the same. So if we wanted to calculate the C, we would do C squared is, take these bottom numbers, we would do bigger minus smaller, and in this case it doesn't matter because they're the same. So we would do 16 minus 16, and we would get C squared is 0, so C is 0. And then over here, we would do C divided by A or B. This is A squared, so A or B, whichever one is bigger. Both A and B are just 4. So no matter which one we did, A or B, we would have 0 for C divided by 4, and then we can see, oh, the eccentricity of a circle is 0. So they're not going to ask you to find it because it's literally 0 every time, but you can see like, oh, that is perfectly circular, and the eccentricity mathematically shows that as well. All right, let's look at an application problem. So it says, all light or sound waves emitted from one focus are reflected off the ellipse to concentrate at the other focus. So sound waves and light reflect and come to this focus over here. This property is used in light fixtures such as a dentist light, for which a concentration of light at a point is desired, and in a whispering gallery, like the one in the US Capitol building. In a whispering gallery, a whisper emitted at one focus is reflected off the elliptical ceiling and is amplified so that it can be heard at the other focus, but not anywhere in between. So that's the way a whispering gallery works, is you'd have a person like in an elliptical room or in an elliptical space. You'd have a person standing here and a person standing there, and there could be a whole crowd of people. You could have a bunch of people, but if this person whispered, only this person would hear it and nobody else. So that's kind of cool, and it works because of how ellipses work. All right, so this problem says the first artificial satellite to orbit Earth was Sputnik 1, launched by the Soviet Union in 1957. The altitude of Sputnik 1 varied from 132 miles to 583 miles above the surface of the Earth. So we've got that kind of pictured here with the orbit. If the center of Earth is one focus, so this is the focus that is the center of the Earth. It's not the center of the ellipse, but it's the center of the Earth. If the center of the Earth is one focus of its elliptical orbit and the radius of the Earth is 3,950 miles, then what was the eccentricity of the orbit? So what I'm going to do is just kind of write all the information out. I'm going to label the picture as much as we can so that we can figure out what the eccentricity is. So if I look at this, I'm going to go ahead and make this center of the ellipse right here. I'm going to make this the origin. So in word problems, it's often good to put your drawing or the modeling problem to put it on an X and a Y axis. So I'm going to make the center of the ellipse, not the center of the Earth. I'm going to make the center of the ellipse at 0, 0. So this is at 0, 0. Try to write that dark. I don't know if you can see that. And so we can see all the measurements from here to here. This is one edge of the orbit. This is the other edge of the orbit. So we can see what that whole width of the ellipse is. And so I'm going to go ahead and figure out what that number is. So we've got 583 miles and then 3,950 for one radius of the Earth, the other radius of the Earth, 3,950, and then the 132. So okay, so 8,615 is that entire length all the way across. And so if I want to figure out what these vertices or co-vertices, I'm not sure. I don't know if they're the longest or not the longest yet. I'm going to go ahead and divide that by 2. Okay, so this is okay. Let's see. So I want to figure out where this focus is, this point right here. And I know this entire length is 4,307.5. And I know that this is 3,950 and this is 132. I don't know how much this is, but that's what I'm trying to find. So I'm going to go ahead and take this entire half and subtract off this and subtract off this to find just this distance. Okay, so this is okay. I'm going to start writing what I have, but hopefully the way that I found those numbers kind of makes sense. So since the center is at 0, 0, the beginning of the equation for my ellipse is pretty simple. X squared, y squared. I can see that this left and right part is the 4,307.5. That's like my left and right radius. And so that's going to go underneath the X. That number squared. I don't know what this is. There's no numbers listed here. There's nothing, no measurements there. So I'm just going to call that B squared. And then this, from the center to the focus, they told me is this length right here, 225.5 miles. And so C squared is just 225.5 squared. Okay, so to find the eccentricity, we just have to do the eccentricity is C, 225.5, divided by either A or B, whichever one is bigger. So if I was in a guessing mood, I could just take this number, 4,307.5, stick it underneath and figure it out, and just assume this is bigger. And they labeled these two as V1 and V2, so that makes me think they're probably vertices, but they didn't actually say that. So what I'm going to go ahead and do is I'm going to figure out what B should be just to make sure that it's smaller so that I know that for the eccentricity, I'm doing the C value divided by whichever one of these is bigger, okay? So I'm going to go ahead and just assume that A squared is bigger. I'm going to say C squared is bigger minus smaller. I'm going to assume this one's bigger, and I'm just going to type in the numbers and see if it works. So 225.5 squared is 4,307.5 squared minus B squared. So I'm going to take this and subtract it over. And when I subtract it over, I should get a negative number because I'm going to get negative B. That whatever number over here is going to equal negative B squared. So 225.5 squared minus 4,307.5 squared. So that's good. And so I'm going to divide by -1 just to get rid of my negative. Okay. And now I need to take the square root of this number. So I'm going to raise it to the 0.5. Okay. 4,301.6. I'm just going to round it to 1 decimal place because this isn't my final answer. I'm just using it for comparison's sake. So if I put this in my equation, 4,301.6, this is smaller. So that means that we did have the correct vertex value to find the eccentricity. And we did a little bit of extra work to make sure that we were right, and that's fine. So 4,307.5 is what we're going to divide here. So we're doing the C value divided by A or B, whichever one's bigger. A is bigger. So we can go ahead and divide that. The eccentricity is 0.052. Which is a number pretty close to 0. So they were doing a very circular orbit, even though it's 583 feet up, or miles above the Earth's surface over here and 132 miles above the Earth's surface over here. In general, the orbit they're doing is very circular, which is kind of cool. It means the Earth is pretty circular.